and I were back there. So they're cooking.
They're cooking.
All right. So example 3 is probably actually, we probably could have flipped these examples. Example 2 is probably a little tougher than this. We probably should have flipped them yesterday and kind of eased more into this. So it asks us to find a polynomial with real coefficients. Don't let the real coefficients sound like more complicated. It just basically is trying to keep this down to an easier level, so it's a good thing. That has zeros of the ones they show us here. Now, if we see these zeros, are there any other zeros we can assume are part of the problem?
2 minus 3i.
The opposites of what though?
The imaginary.
Just the imaginary one, yeah. So just because you have -1 and 3, those other ones are not, like, so 1 and -3 aren't necessarily zeros. But when it's imaginary, we can automatically assume there's also going to be a 0 for the conjugate of that. So we're going to include that as well. So we have to include that one. Now, it says find a polynomial. Now, there could be many more polynomials because they don't tell us what the degree is. We just want to find one, so we're going to find kind of the easiest one out of all of them. So what is our degree going to be for our polynomial we write?
4.
It's going to be 4. Now, technically, this polynomial could have other zeros. They don't list them, but we don't know for sure, so we're just going to stick with what we have right now. So we have to write our factors. So again, we're doing x, like basically minus our 0. So x minus -1. And if you're able to just write that as +1 right away, that's fine. X minus 3. And then the 2 that we don't really like doing here, x minus So I'll rewrite this again, kind of without all the extra parentheses and stuff. So this is x plus 1, x minus 3, and then there we can distribute those negatives in. Now, in tonight's homework, they will want you to FOIL it through, so like rewrite it as a polynomial, not in this factored form. And so I'll try to be specific on the test, if you can leave it in factored form or if you want to distribute. This book is kind of vague about a lot of things. Yeah, the wording sometimes is strange, but this one, tonight we want to FOIL this all the way through. Now, I would choose to FOIL kind of the 2 pairs separately, so like I'm going to look at these and then these. As much as this is a pain, it's better than like combining like different parts together first. So I'm going to kind of FOIL this first one here completely. I'm going to change colors for this one just because I want to kind of keep it sorted out here so I don't lose anything. Draw more line here. So I'm going to multiply the x by everything. Now this is 3 times 3, so there should end up being 9 like terms. But again, notice the i's are going to end up canceling, which is good, but we just have to notice that. My first one, and let me know if you guys see me do something wrong, and it's totally possible. So. And obviously we'll just finish the homework. Thank you. Alright, so a bunch is going to cancel here. This becomes positive 9 over here. Alright, so again, are we okay with what we got here?
Yep.
So we're going to get in the habit of doing this with these conjugates and we multiply them together. Hopefully you guys get better at noticing what cancels. To be honest, I don't even write these ones because I know they're going to cancel just to save myself some time. So kind of like trying to streamline that process a little bit.
You just distribute again.
Yeah, now we have to distribute this one more time to find our polynomial. So yeah, just finishing the homework then. I'll put the rest of the video on there. And then there's a whole bunch of like terms. You guys have the same thing here for me? Mistakes on my part. Hopefully not. (13 and 8 is 21 minus 3. 18. I think that should be right. Is that what you guys got too? Okay, good. There's so many places to make mistakes. I'm going to trust that if we all end up the same one. So there's a lot of work there, so maybe this wasn't a bad thing to not do yesterday. I don't know. These are long problems. The good news is the one on your homework is only x to the third. A little bit smaller than that one. All right, I'd like to talk to you guys. Is number 10 listed on there?
Yeah.
Okay.
We don't have to.
I didn't have it on my answer key, but I must have. Okay. We all good with this?
Yeah.
Yeah. All right. So I want to talk to you guys about how this connects back to the graph. So talking about our warm-up question yesterday, I had mentioned I was going to kind of connect all this together, but then we ran out of time. So this graph is a real graph, even though it has imaginary zeros. What do you think this graph would look like then? Do you think it's going to be a squiggle? What do we know about a quadratic x squared graph? It's a U. Now remember, the zeros are where it touches the x-axis. So if the zeros are imaginary, what do you think that's true about the graph? It never touches the x-axis. So I'm assuming this is probably going to be above the x-axis. So let's see if we have. Well, because the graph still exists, though. The graph's still like a real graph. So The imaginary zeros is so there's an answer, so we have an answer to every question. Yes.
So it never tests 0, and it's still a 0.
It's an it's not real.
You're blowing his mind.
Sorry, thank you.
Could we make up imaginary zeros for anything then?
Not necessarily.
No, because they do have applications. It's a plus 25, yeah.
These imaginaries are numbers.
Now, it's not going to show up on my graph because, oh, it's up there. So you can see it.
So we just imagine that the graph hits 0.
No, it doesn't. We don't imagine it. It's just where it hit would be imaginary.
Make A's taking adjustments to the
What's that?
Make A's taking the
Oh, I changed the wrong 30. Anyway, so you get the idea though. It never touches the x-axis. That's why the zeros are imaginary. So, so a graph like that has answers that just aren't real. So, talking about that brings us down to these little polynomial graphs here. Now, I don't know if we use the word simple, real, 0. Simple just means there's only one of them. So there's only 1 0. So it means there's no repeats. So they said the curve below is a graph with a polynomial with degree of 5. Insert a horizontal axis consistent with the information given. So if I was trying to draw a horizontal axis, like if I was drawing, like, where would the x-axis be? If it only has 1 0, where am I going to put it?
On the bottom.
You can put it on the bottom.
Or the top.
Or the top, yep. So we just wanted to hit the graph one time. So this would be an example, otherwise you could also move it up to the top. So it should only hit the graph one time. So this same shape can have different criteria depending where the axis is. The next one has 1 real 0 and then a real 0 with multiplicity of 2. So that means the 0 repeats. What do you think that looks like on a graph? If the 0 repeats, so basically x equals 2 happens twice.
It's like your normal graph that stays out.
Stays there? How does it stay? You have the right idea. I'm just trying to kind of play it, get a little more detail.
There's 2 x-axes. That makes sense.
No.
Anyone think they know?
No.
All right, I'll draw it and then we'll try to explain the why. I might have to move it. So that's supposed to be touching there. Why is it just touching there? What's happening? So the difference is, does it go through it or does it touch the graph and then change direction? So this is the simple 0, this is the 1. Then this one repeats, so it hits it, but then it does something different at that point. So multiplicity typically means that it probably is just going to kind of bounce off the graph at that point. So this is multiplicity of 2. Whereas multiplicity of 1 just goes through the graph. It's a simple. So if the solution repeats, it's going to we say bounce, or it will change direction at that point. Now this last one's kind of a strange one for this one. There's no real zeros. What's that? We can't, because this one's gonna hit the graph on either there's no way to draw an axis because of those arrows that continues on forever. There's no way to draw. So this one is not possible to have no real zeros. Now our quadratic had, our warm-up had no real zeros, but this one, there's just no way for that to happen. There's gonna be a 0 that's real. So this one's not possible to draw. Okay.
I feel like it starts to make more sense once you talk about the graphs.
Yeah, and again, that's really that's deep, Stone, thank you. Yeah, the graphs, as much as they don't seem helpful, there is that point, it's supposed to make more sense that way.
Yeah.
So I'm glad that you think that. So we just have the next 4 questions to do. Yeah, I think you guys should be fine with it. We get out of here at 50, and then we're going to the assembly, and then go to second hour from there. So they do give us a little bit of passing time, but to get in and kind of get situated, you might want to, like, you can leave your stuff in your, I don't have a second hour, so you're welcome to just leave your stuff and then come pick it up. Yep.
I was gonna ask how long it is, but then
Yeah, it's technically, I think, like an hour, 50 or whatever, yeah. All right, questions?
Dude, let's go. Only an hour.